Let's try our last two problems. Now, to save a little time on number 4, I already went through and found the derivative. It is a product rule because you have a first times a second. And when I set up the product rule and took the derivative of the second, I also had a chain rule in there. So I did all that, and then I simplified it down to get that. So I am at the step where I need to find my critical numbers. So I'm going to start with setting it equal to 0. And when I'm setting it equal to 0, I notice that these have a GCF of e to the negative 2x squared. So I'm going to take that out. And I should be left with that. Oops, sorry, this should be a negative 4x, which makes that a positive. Let me fix that real quick. Thought something was wrong there. There we go. Okay, and I also noticed that this is a difference of squares. This is 2x minus 1, 2x plus 1. And now I can set all of these pieces equal to 0. Now I'm going to note this exponential, it's an exponential. It's never ever going to reach 0. That's an asymptote. So none for that one. But these other ones I can solve really quickly. So I get x equals a positive 1/2. And x equals a negative 1/2. Excellent. And where f prime is undefined, this is a polynomial and an exponential. They don't have any asymptotes, so they're never undefined. So, none for undefined. Now I need to test my critical numbers. So the only ones I had were negative 1/2 and positive 1/2. So let's test these out. Let's say f prime of negative 1, f prime of 0, and f prime of positive 1. So I want you to pause the video, try to plug all those into my derivative to see what the signs are. Make your sign line, and then try to find your answers on your own. So I got it started for you. I want you to try and finish. So pause the video and try that out. Welcome back. Check what you got with what I got. I plugged these in. I got positive, negative, positive. And by the way, you can see I plugged them into this version of f prime rather than this version. But they are equal to each other, so it doesn't really matter which version you plug it into. Either way, I got increasing, decreasing, increasing. So there's my increasing intervals and decreasing intervals. And now I have a maximum at negative 1/2, a minimum at positive 1/2. And remember, I plugged these into the original equation, not the derivative, to get the point. So I plugged those into the original, and that's what I got. So that should be your answer. Okay, one more. This is a polynomial. So I want you to try this one out on your own. Find f prime. Find your critical numbers by finding where f prime equals 0 or undefined. There we go. And then test your critical numbers on your sign line. And write your intervals of increasing and decreasing. Pause the video, try it out on your own. Welcome back. When you found your critical numbers, you should have only found x equals 1. That's our only critical number for this one. It's never undefined. So I put x equals 1. I test some numbers, find out that it's positive to either side. Now this is an interesting function. This is one of those cubics that goes like that. So it is increasing the entire time. It is never decreasing, and it doesn't have any maximums or mins. And that's what this last point is getting at. The function in example 5 is a strictly monotonic function. That's a new vocabulary word for you. It is strictly increasing or strictly decreasing the entire time. And this illustrates two very important points. Number one, not every critical number is going to give you a relative max or a relative min. Some critical numbers are not maxes or mins. So that's why we need to do a sign line every time. You do that sign line to see, is it a max, is it a min, or is it none? And example number 2, even though the slope at x equals 1, so the tangent line at x equals 1 is 0, the function is still always increasing. So, there's the last for this lesson. You should be able to get started on your assignment.